don't really know on Earth why you get thunderstorms at the rate we get them. We look at Saturn, they're very infrequent.
We were pretty sure that lightning exists there, but we actually couldn't see it. It's a giant planet with huge atmosphere, and there should be a lot of weather there.
We had heard the lightning on the radio instrument on Cassini, but you hear static on the radio signal, but you can't pinpoint where it's coming from. We had to use a synthetic noise because the actual noise that the radio instrument is picking up is beyond the human ear. So we picked a noise that sounded like an electrical discharge. In other words, a big spark. That's what lightning is. We pointed the cameras there, and wonder of wonders, there were lightning flashes, and took a series of pictures. And in one picture there'd be no lightning flash, and the next picture there'd be a lightning flash. And at the same time, you hear the noise over the radio instrument.
And we actually saw it. I didn't believe it.
The lightning storms on Saturn are very much like lightning on Earth. You get the same strength lightning storms, or thunderstorms. They have the same strength, but they're just much less frequent. I'm enjoying the show.
Lightning across the solar system. Presented by Science at NASA. Lightning is as beautiful as it is powerful. A violent, hotter than the surface of the sun electrical marvel. But might lightning on other planets be even more astonishing? Consider this. When Voyager 1 flew by Jupiter in 1979, its imager captured areas nearly as big as the U.S., lit up by lightning in Jupiter's clouds. Voyager also captured other, less flashy signs of lightning. University of Iowa physicist Don Gurnett is one of the scientists whose Voyager instrument detected radio waves called whistlers, signs of lightning. New Horizons cameras captured lightning flashes on Jupiter 10 times as powerful as anything ever recorded on Earth. And recently, Juno, flying closer to Jupiter than any previous mission, found that most of Jupiter's lightning is around the planet's higher latitudes, unlike Earth, where lightning strikes primarily over land and most intensely at the equator. Juno detected peak rates of 4 strikes per second, similar to rates on Earth. On Earth, lightning forms because colliding ice crystals and water drops inside clouds create positive and negative electric charges, which become separated by convective forces. When the charges become separated enough, a lightning bolt discharges. Something similar happens on Jupiter. Gases, including water vapor, rise from deep within the planet. As they freeze, ice particles become separated from the water drops by convection, building a charge, which is discharged as lightning. Lightning has also been observed on gas giant Saturn. In 1980 to 1981, Voyager detected radio signals called sferics, which, like whistlers, are signs of lightning. Gurnett says, on Earth, you can hear these high-frequency radio emissions on your car's AM radio as radio static during a nearby lightning storm. Cassini recorded similar emissions at Saturn, revealing that for strong storms, lightning occurred as many as 10 times per second. Gurnett has been involved in the search for lightning on other planets across the solar system as well. Venus, for example, has a hot, dry atmosphere made up mostly of carbon dioxide suffused with sulfuric acid. Could this brew become electrically charged and generate lightning? When Cassini flew by Venus twice, in 1998 and 1999, Gurnett did a search for lightning with a radio instrument perfect for detecting signs of lightning sferics. However, the instrument picked up no signs at all. That same instrument easily detected sferics during a similar flyby of Earth 2 months later, leading him to believe that there is no Earth-like lightning present on Venus. The European Space Agency's Venus Express orbiter has picked up bursts of electromagnetic waves some scientists attribute to whistlers, but others argue that the instrument's frequency range was too low to detect the usual forms of whistlers. Gurnett has used Mars Express's radar system receiver to conduct a 5-year search for lightning associated with dust storms on Mars. That search didn't find lightning. However, images from the Mars Global Surveyor show bright flashes in dust storms, as well as craters on Mars that some scientists believe to be evidence of lightning strikes on the planet's surface. Stay tuned as this electric story unfolds on Science.
Think satellite, you're thinking something the size of a car or bigger. It's the size of a loaf of bread, and that's our satellite. There's been some evidence that lightning produces gamma rays, and this is really the first satellite that's going to go out and investigate if and how and where and everything associated with gamma rays coming from lightning. There's been evidence, and others have seen this, but again, there's never been a satellite dedicated looking down at Earth for these terrestrial gamma ray bursts.
We want to make artificial signals similar to lightning and see what the board does, make sure it's filtering those signals the way we want.
We're going to put it into HDL code and then get it through this chip.
One of the tenets of the CubeSat program is to involve undergraduate students at all levels, from design to building to some of the theory, data acquisition, every aspect of this. So we're really training here the next generation of space scientists, of satellite engineers. As soon as the launch goes up and they know they're a part of that satellite and data's coming in, I mean, that'll be with them throughout their life.